Constants are a special kind of variable that you'll use in your Python programs and in other languages that allow you to improve the quality of your code and make it easier to understand. Before we talk about what exactly constants are, let's talk about the problem that they solve. When you're programming, it's frequent, especially in your early days, that you'll want to use concrete number literals, float literals, int literals, or string literals scattered throughout your code. This is a very natural thing to want to do. And these literal values make sense to you when you use them. Like, of course, you're trying to solve a particular problem at the time, and you use this number that made sense to you when you wrote the program. But when someone else comes along and tries to read your code, it's going to take some effort on their part to understand, well, why did you choose this number here? And it feels like that might be kind of a magically chosen number. Like they don't know your reasoning for having chosen this number without there being some other indicating logic or comment or documentation that would support it. And so we call these magic numbers or magic strings when there are just values scattered about throughout your code that are literals, and they don't seem to have a rhyme or a reason for being there, but of course they need to be there. So we've got to find a way out of this. And this problem doesn't only apply to other people, but it applies to you in the future. Future you, when you look back at your code a month from now, 3 months from now, you're going to sit there and be like, what was I actually doing or trying to do here? Why did I choose that particular number in this particular place? The other issue you'll run into is there's a very high likelihood that if you use a magic literal or a magic number string in your code in one place, highly likely that you're using it in other places as well as you start writing more complex programs. And so what happens when you want to change one of these values? Well, then you've got to go search for it and replace all of your different instances, and you might forget one. And it becomes a much bigger, what we think of as a maintenance problem to maintain your code and play with it in the future. Because the same value is scattered about in many different places, it takes extra work in order to change it and try a different value instead. Right? If we wanted to add more digits to pi, and we're assuming 3.14159 is pi, if we use that in many different places, we would need to go update all of those places to be consistent. So named constants are our way out of this, and they're a special form of a variable that we declare and initialize and then never expect to change again. In fact, the point of a constant is implicit in its name, or explicit in its name, I should say. It's a constant. We're not going to change this value. It's constant for the life of the program. Now, if we want to go back and rewrite our program and change the code of it and then rerun our program with a different value, that's totally fine. When we say constant, we mean once you start up a program, for the duration of that program while it's running, this value should never change. We use a special naming convention that is shared throughout just about every programming language that has the notion of constants. And that is all uppercase letters are going to be used for the names of our constants. And this makes them readily and easily identifiable and different from your variable names, right? Your variable names in Python, we're using snake casing, which are all lowercase letters, separated words by, and we separate words by underscores. Here with a constant, it looks and actually is a variable, but we're going to use all uppercase letters to differentiate it from a normal variable or other things that we have names for, like functions. So we'll use all uppercase identifiers. You could imagine if we had a version string such as 3.8.5, we would name that constant capital version, or we could have a pi constant. I should note that you should probably use the library's built-in pi if you're doing trigonometric computations. There's one that will have much more precision than that, but just as pi is a constant that we're all familiar with, so that's why I chose it as an example. Where do you define your constants? Well, typically what is conventional is after your imported statements in a Python program. We'll get a chance to look at this in just a moment. That's where you'll declare your constants. So they'll be towards the top of your file. And that way, when someone's reading your program and you're seeing, okay, well, what are the things that we're importing from different places? And then, okay, what are some of the constants that we might see used throughout our program? And then once you define your constant, rather than using one of these magic numbers somewhere else, you'll just reference that constant with a variable access reference in whatever expression that needed that magic number or that magic string. Right? So for style purposes, Anywhere you use a magic number in your program, you really shouldn't. You should go ahead and define a constant at the top of your file, just beneath your imports, and use that constant in its place. And that way, if you need to use it somewhere else, you can. And if you want to change the value you're using for this, like we're on to the next version, and maybe we do 3.9.5 for our version, you only have to change it in one place now because you've declared it as a constant, and that value is going to be global to your file. All right. So what we're going to do next is move through a follow along code exercise where we can not only use constants and show that, but get a little bit more practice with functions. We're going to declare two functions that generate, one will give us a random letter and one will give us a random word made of 4 letters concatenated together at random. Right? So let's jump into VS Code, and I'm going to set up a new file by right-clicking my lessons directory, and we're going to name this ls09 constants.py. Right? And we should go ahead and drop in some documentation here. So my documentation might be some examples of constants and functions. All right. So the doc string at the top is just a good way to document what is the purpose of your program. And now, and I might go ahead and make this just slightly bigger. We'll see if I've got space. I'm going to hide my file explorer as well so that you can see more of my screen. Now let's define some constants. So the two constants that we're going to use are going to be for vowels and consonants. And we're going to be generating words at random by picking either a random vowel or a random consonant. So we're going to have these magic strings that are made up of only these character sets. So we can declare a constant, vowels, which will be a string type, and it will initially be A, E, I, O, U, Y. We'll be controversial here. Y is clearly a vowel. If you disagree with me, let me know in the chat. And our consonants, if I could spell, is a stir type as well. And we've got B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Z, because Y is clearly not a consonant. And okay, great. We've got two constants defined in our program right now. Right? And so if we wanted to, we can save this program. I'm going to use my Control S on Windows or Command S on Mac. And I'm going to open up a terminal just to prove to ourselves that these were successfully defined. Right? And what I'm going to do is I'm going to start up a REPL, so Python. And we see that I'm working in 3.8 or greater. And we're going to import these two constants just to see that we can. Right? So what we can say is from, and here we need to give the Python module name. And the Python module name is made up of the directory names that lead up to the module. And so our module is the Python file, and the directory names are those directories that come before it. So in this case, we've got the ls09 constants file in the lessons directory. So I can say lessons, that's our directory, or we think of that as our package. Dot ls09 underscore constants, and that is our module. You know it's a module because it ends in .py or for Python, but we don't, when we're importing or when we're running a file as a module, you don't need to include the .py, and in fact you would have an issue if you did. We leave that off when we're thinking in terms of modules as we are here. And what we're going to import from this file are both vowels and consonants. All right. And so now, because we've imported those constants, if I were to ask, well, what is, if I evaluate this variable access reference, they're my vowels. And if I evaluate consonants, sure enough, there are my constants. All right, so we've got these two magic strings made up of these letter sets, and that's all we need to do in our REPL for now. So because any change we make in our Python file won't be reflected until we restart a new REPL and re-import, I'm going to go ahead and quit, and I can close this terminal from now. We'll come back to it. So we're going to be doing some random selection, and there's this really cool function built into the random package in Python called choice. And what choice does is you give choice a sequence of items, and it makes a choice for you at random and chooses just one of them. And so here our sequence is going to be these strings, so we can make a choice of any of our vowels or any of our consonants, and that's how we'll generate a random letter. As I mentioned, we tend to, by convention, place our imports above our constants, or place our constants below our imports. So from random, import choice, right? And so choice is a function defined in the random library. And if you see any red squigglies, it probably just means that you haven't used this function yet, and that's okay, we'll get there. If you don't, that's great. They're kind of a nuisance right now because we're about to go write a function called random letter that will actually make use of this choice function. So let's define a function. So we're gonna use our def syntax. We're defining a new function, and we'll name this function random letter. And we're gonna have to specify its parameters. So the point of this function is gonna be, we give it a string that makes up the letters we want it to choose from at random. And what it's gonna do is give us one letter from that string back. We don't know which, that'll be completely random. So we'll say letters is the name of this parameter and its type will be a string. So we're saying in order to call this function, we're gonna have to give it a string argument that will correspond to this letter's parameter. And this function will have a return type of string. So now what we can do is we can say, well, okay, let's define, first, what's the point of this function? Let's set up its docstring here. And so the docstring is gonna be given an alphabet, select one letter at random, okay? So the letter is gonna be a string, and the way that we're gonna get the letter, and this is a string variable that we're setting up inside this function. So when this function runs, there will be this variable that will be assigned a choice of the letters. Okay? So this choice function, when we call it and give it a string, remember, it's gonna give us one of the items back. And when we learn other types of sequences, we can actually use the same function for other types of sequences as well. A string is a sequence of characters. We'll see that there's things like lists, which are lists of other types of values. But here, because our string is a list of characters, when we use the choice function, it's just gonna give us back one of those letters at random. And we will return letter, which satisfies the return type of this function. So this function says, hey, when you call me, I'm gonna give you back a stir, but it's just gonna be a stir whose length is 1, has a single character. All right, so now that we have this random letter function defined, let's try calling it from the terminal. So I'm gonna open up a new terminal. And I'm going to begin a Python REPL. And the first thing we're gonna do is from lessons.ls09 constants import random letter. And why don't we import one of those two like vowels, say constants that we set up, so vowels. Okay, so now random letter is a function that we can call. So if we say random letter and we ask for one of our vowels, we get I, and each time we call this, so if I just press up and then enter, notice I, E, O, I, O, A. So we're picking one of those letters at random. To prove to ourselves that this function is general purpose, we could also just pass it a string literal instead, a magic string like foo, A, B, C, D, E, F, right? And just to prove to ourselves, okay, E, D, F. So each time this function is being called, now we're giving an argument of this string, A, B, C, D, E, F, and that's going to be sent to or passed to this letter's parameter. And then when we make the choice in this function, evaluation, it's going to pick one of those letters from this string at random, and then it's going to return that back. So when this function call expression that we wrote here evaluates, it's going to result in just one of our letters at a time, okay? And in a cool way, because this is a string expression, right? Because this is a string parameter that we need to pass. So any string argument expression can be used. We can use one of our constants here in order to reuse the letter set that we chose above, right? And so cool, we've got this working. All right, I'm gonna quit this REPL. And okay, we didn't really set out to just generate random letters. We wanted to actually generate random words. And we'll limit ourselves to 4-letter words here, okay? So I'm gonna define a function named random word. And this is gonna be an interesting function. It's not gonna have any parameters defined on it yet. And that's okay, you don't have to have parameters. It's pretty frequent that it's more frequent that you will have parameters defined than not, but some functions don't need it, right? So here, this is going to be a random word, and we don't get to give it any inputs. It's just always going to result in a word of length 4 given back to us. So the return type is going to be a string, and this docstring will describe what we're doing here. So what we're doing here is generate a random 4-letter word. Okay. So what's our algorithm for generating a word? Well, we probably want to build up a string character by character, and we know that we can concatenate a string and reassign that concatenation back to some other variable. So maybe we set up a variable named word that is going to be of type string, and it's initially the empty string. Right? Oftentimes, one of the strategies that I like to take when working on a function is set up this variable that I'm going to use to accumulate some result. And here we're going to build up this word step by step, or letter by letter in this case. And ultimately, we need to return this word, right? For this to be a valid function that returns a string, we need to remember to return a string. And so by doing so, right now, this is not a correct function implementation, but it satisfies the type constraints. So before, notice if we didn't have that return statement there, we're going to get some highlighting that says, hey, you declared this function to return a string, but you didn't actually. There's no return statement in here that returns a string. So let's be sure that we return a word. And now the question is, what is the algorithm we're going to use to build up this word? You know, we didn't have to initialize this to the empty string here, so I might just declare it, because this is one of those cases where just declaring the type of a variable is fine. And we can initialize it on the next line, which is word is going to be assigned random letter. And let me make use of, let's see, do we want our word to start with a consonant or a vowel? We'll do a consonant, right? Consonants. If you're typing in VS Code and you see that the word that you're trying to type is the top choice in this selection of choices, that autocomplete will work for you if you just press enter at that point. So if you write enough of your word to get the top choice to be what you want it to be, autocomplete can fill in the rest of it for you, and that's a pretty nice feature. Oh, I'm just realizing, notice there's this little squiggly here that says, hey, I've got an extra double quote. I have 4 instead of 3. So remember, our doc strings have 3 on each side. So sometimes you'll see that you accidentally mistype a character, and look for some of those red squiggly underlines as an indication that maybe your syntax is off somewhere. All right, so our word has 1 random letter in it now. Well, let's add another random letter. So if we want to grow a string or create a new string that has 1 string concatenated with another string, what do we do? Well, this is kind of like increasing a variable relative to itself. We can access the word that we're building up here. So we're going to say word is going to be bound to the current contents of word concatenated with another random letter. And that random letter might be a vowel, right? And so notice that vowel is underlined because my constant is named vowels, right? So it's going to tell me, hey, vowel is not defined, but I have a variable named vowels with an S. Spelling, capitalization is precisely important. You can't get it subtly wrong and have your programming language know what you meant. You have to get your variable names, your function names to match exactly in both case and in spelling, as well as any punctuation like with underscores. Okay, so we've got a consonant followed by a vowel. Maybe I might just copy this line above and have another vowel, and notice that we're repeating the last thing that we just did before us. So we're saying, okay, take the current value of word and concatenate on another vowel, and then store the result, the new string that's been produced out of this concatenation, back in as being bound to the word variable. So now word has 3 characters in it, and maybe we do this one more time and concatenate with a random letter that is another consonant. All right, so now we should be, when we call this function, it will return to us a random string made up of a consonant followed by 2 vowels followed by a consonant. And notice here we're building up a string by concatenating the string or concatenating onto the end of the string and then reassigning that value back to the variable itself. So we're emphasizing some fundamental variable concepts here. So let's give this a shot. I'm going to go to my terminal and run a new terminal. And this time around, because I don't need my constants, we can just import this one random word function and see if it works. So I begin my REPL, and one of the things that's worth pointing out is being careful to always reference your package directly when you're importing. So from, and remember the package name is made up of the directories that it's in, or you can think of those as folders, lessons, dot, and then our module name is ls09_constants, import random word. Great. And so now if we call random word, we've got this interesting conundrum. This is a function that defines no parameters, so how do we call a function that defines no parameters? Well, we can call it by providing no arguments, right? We just use those parentheses, and those parentheses are saying, hey, actually call this function. This is what makes this a function call expression. The name of a function followed by a pair of matching parentheses. So we do that and we get Veek, right? And yours is going to be different. I try again, poos, try again, hive, seam, and you kind of get the point. Notice that we are doing some really interesting things here. We are calling a function with no arguments, and its algorithm is then calling another function multiple times over, right, to build up a bigger result. And so we're composing two functions together here. We're saying, okay, we're going to write a simple function like random letter, and then a more complex function in terms of that simpler function. Here, random word calls random letter 4 times over, right? And pretty soon we'll learn, well, how could we do this as many times as we wanted? It seems like there's got to be a better way of doing this. And that's what we're going to be getting to next with a concept called looping. But for now, we're focused on function call semantics. One other thing I want to point out here is if I reference the variable, or sorry, the function name, random word, notice that if I don't include those parentheses, Python is telling me, the REPL is telling me, I am referencing this function definition. And this is a memory address that you don't need to worry about. But what's important to sort of make note of here is we're saying the identifier random_word is a function. And sure enough, that's what we imported, right? But that's different from random_word with parentheses right after it. And notice that's what's actually calling the function. So we can refer to the function by its name without any parentheses, and that's us referring to the idea of the function without actually saying, hey, go call that function, go carry out that subprogram. Or if we include the parentheses just after it and any parameters that function needs, that's what actually calls the function. So this is an introduction to constants, and notice here, if we wanted to change the constants by choosing different vowels, like if we wanted our generated words to use only O's and I's for our vowels, we could change it in one place. And because we used named constants instead of magic strings, we don't have to update anywhere else in our program that referred to that character set. It would automatically happen. And same with constants, if we wanted only BCD, that would work just the same. We could update one place, and anywhere we referenced that named constant, it would be, when the program next ran, it would be updated. VS Code is giving you some color coding as well. And if you highlight one of these variables, you'll see that it's also telling you, hey, because of the convention that you named this variable with all capital letters, we know this is a constant and we're going to treat it as such. So you should never reassign or attempt to reassign to a constant. The point of the constant is to stay the same throughout the running of your program. And the point is to avoid encoding any magic numbers or magic strings in your programs. That'll lead to much cleaner code. Happy programming.